I'm gonna do the recording now. Cool. So there are two information to share. First, if you haven't downloaded today's script, you can find it. There is a Google link there. Also, if you are not on our newsletter list, you can go to nycdatascience.com, scroll down to the bottom, and subscribe to our newsletter. So we send out newsletter once per week. We aggregate the content from previous events. Feel free to engage with us through the community. Okay, so my name is Vivian. I'm the founder and the Chief Technology Officer of the Academy. Today I have my colleague Manisa and Alex join me. Manisa gonna start with a 5 minutes brief intro of who we are and what we do. Alex is one of our most loved instructor here, and he's gonna teach some coding here. Okay, let's get started.
Thank you, Vivian. As Vivian presented me, my name is Monisa. I'm one of the admissions officers here in the school. And before we start, I know everybody is very excited for today's event, but I promise it won't take a long time here. Let's talk a little bit about who we are. And if you are here in this event today, I'm pretty sure that you're interested in data science. Maybe you're already studying, maybe you're planning to study. And we are a school and we offer data science boot camps. It's an accelerated program to make sure that you are able to do a career transition or start getting to the industry of data science. So we are proud to say that we are the only boot camp teaching two coding language programming, very important for data science, Python and R. Also, students that join our program had the opportunity to work with 4 industry projects, lots of hands-on practice, and a lot of orientation on how to be your best data scientist, data analyst in the industry. Job placement, yes, we assist all our students to get into the job market with job placement. We have a team and we will help you, assist you with your resume and mock interviews and anything that you need to go out there in job market and put your best data scientist persona and get that job. We have experience doing this. We've helped over 2,000 alumni and we keep counting, it keep growing. And also, not to brag, but we were rated best data science bootcamp and best online data science bootcamp by SwitchUp in 2020. So we are very proud and we love data science, and that's why we're here today. Just a quick reminder that if you're here because maybe you're planning to study data science and you're interested in our programs, we are accepting applications for our upcoming bootcamp start dates. We have a 3-month remote live program, and that next start date will be May 3rd. We have one that's a little bit late to start, which is April 6th, but you know, students are very excited and it's starting next week. And but you know, it's not that one, maybe it's a little bit too late, but we have another one starting May 17th, and I highly recommend you to start your application now if you're considering the May 17th start. For the May 17th start, it's the part-time online bootcamp and full-time online bootcamp. As you can see, they have a slightly different duration time, but all these 3 options that I'm talking about, they have the same curriculum and a lot of one-on-one guidance for anyone interested. I'm very happy to answer any questions you guys may have. I'm going to be here on the chat. Feel free to send questions to me. Or if you want to, you know, just focus on the event, which I highly recommend as well, very important. You can send an email to admissions@NYC Data Science Academy. We can potentially schedule a call and go over more details of our bootcamp programs. And yeah, and like Vivian mentioned, if you want to, you know, follow these event today, make sure that you download the documents that will help you with the scripts. I'm going to just put here on the chat one more time so Alex can start the event. Thank you, everybody.
Thank you, Monisa. Hello, everyone. Good afternoon, good morning, good evening, wherever you're coming from. Today, I'm very happy to be here to give you a little introduction to web scraping, or maybe a refresher. I see some familiar faces here, so always good to refresh your skills and make sure you're on the right track. Before we get started, if you guys are unmuted, or if you're unmuted, please go ahead and mute, because I'm like a cat with shiny objects. If I hear typing in the background, I'm gonna lose my train of thought. Also, if you see me grimacing for any reason, my back has been kind of hurting me the last couple of days. So it's not because I don't want to be here, it's because my back is bothering me. So with that being said, let me share my screen and we can get started. So this is the notebook that that I've created, that we've sent out to you guys, and this is what we'll be using today. I have a lot of content here to follow, and I do want to do some live coding stuff and kind of showing you what I would do from scratch and stuff. So once we get to the part of the example later, I might end up just ignoring the code depending on how much time we have and in this notebook, because it's really all the steps are all laid out. And I wrote this notebook in a way that if you have to leave because, you know, let's say I go over an hour or something, I've got about 50 minutes left, but let's say I go over that and some of you have to leave because you have work or something like that. The recording will be there, but this notebook is totally, you know, self-sufficient. You can go through this and it should explain every step very clearly. So you actually don't need the video to follow along with this, although you will have it when we have the recording, okay? So that being said, Manisa already did an introduction to our academy and our organization. If you're interested in learning more with us, we have a ton of different offerings and different programs you can look into, from the boot camp or even professional development if you're just looking to increase your Python skill or R skill or machine learning or even other technologies. What we're talking about today is web scraping. And web scraping is one of my favorite topics. It's really fun to do. And because not only is it a good opportunity to get data that may not exist in a structured format. So, you know, for example, data that's stored online that it doesn't exist in a CSV file or it doesn't exist as any of the sort of structured data that we would want to use. But we can extract that and actually use it for data analysis later on, which is really cool. But in addition to that, the process of web scraping is actually a really tremendous way to expand your coding skills, because you're constantly dealing with errors, you're constantly dealing with exceptions and trying to figure out workarounds and things like that. And having to work through that in this coding environment can really expand your skill set and keep your skills sharp and make sure you're using good coding convention and things like that. So web scraping is really a good opportunity to, not, like I said, not only just collect data, but also to keep your skills current and make sure that you're good at debugging, because you're going to be doing a lot of that when you're web scraping for the most part. So what is web scraping? Web scraping is the process of taking information on the web and storing it in a structured format, right? So we're going to define a bunch of rules that allow us to parse out certain information from raw HTML code, okay? And then we save it in a structured format like a CSV file or something. That usually is what we go to, which we're going to do today. And then we can use the data to perform data analysis or to augment additional data sets, existing data sets that we might have. We might want to merge it with some additional data so that we have some more features to play around with for like machine learning, for example. So I'm going to give a brief introduction to, I should mention, by the way, if anyone has any questions during the lecture here, just feel free to write them in the chat. I'll do my best to answer them promptly, or if I feel like it's more relevant to keep it till the end, then I'll leave that. But just feel free to chat, send in the chat, or you can even PM me if you want to, if you don't want to share it publicly. Okay, so what we're going to do today is I'm going to give a brief introduction to web scraping, and then we're going to talk about the anatomy of an HTML document, which is going to be really useful and necessary to understand how to find the items that we want to extract from a web page. So that's going to be relevant later. Then we're going to talk about Beautiful Soup, which is a library that has a class inside of it, which is essentially just a text parser. And what that does is essentially takes the HTML code and searches through it and organizes it for us, so we can find pieces inside that giant text document a lot easier than, for example, like using base Python methods and things like that, like string methods, finding things, using regular expressions, which we can also use if you have experience with that. But Beautiful Soup makes the syntax much easier. Again, if you're unmuted, please go ahead and mute yourself so that there's silence in the room here. Thank you. And then we're going to talk about the request library, which is going to be another library that allows us to download the source code from the web pages. And so we'll talk about that more a little bit later. And then finally, we'll have a Metacritic example that I put together for us.
Alex, I'm working on muting people, don't worry.
Thank you. All right, so let's get started here. So let's cover some basics here. So what we have is we're trying to extract text data from websites, and the websites are rendered in a web browser, right? So like, for example, here I have my Chrome. I can go to, I don't know, like Best Buy or something, and we can see here's the page that we're viewing. But the underlying structure of this is source is HTML code. So we can click the inspect tool here, and we're going to get into this a little bit later. But we can see here that this is really what's going on under the hood. This is what's forming this web page. And really, regardless of what browser you have you're using, the web page is going to look very similar to this, or the source code is going to look like this. And so the source code is organized by these things called tags. The tags can have things called attributes. And within these tags, there's a whole bunch of values and things like that. And the values of these tags are generally what we're going to be scraping or taking the data out of. And the data is going to be in the form of a string. So let me just see if I can find something here. So here, for example, we have a title tag. You can see this title here. Uh-oh. Of course, this is dynamic here. Here's my title tag. And within the title tag, if you caught it, there was some text there. And so, for example, we might want to grab that text and save it in a CSV file or something. A good example is scraping maybe a whole bunch of review items and doing some analysis on the different ratings that are given to a product or something like that.
Alex,
yes.
Would you slow down a little bit to show people how you open up the inspector tool?
Yeah, sure. That was just kind of an example. I'm going to get back into this later, but if you guys want to see for now, I'm sure you guys have all done this before, but if you press F12 on your keyboard, it will pull up the this inspect or this console here. And then here we want to click on elements, and that will show you the HTML source code. You can also right click on the page and go down to inspect, and there's also Control-Shift-I. There's a whole bunch of different ways you get there. F12 is usually the fastest way to do it. But I'm gonna go through this again in depth once we get to the example and when we're actually going through and scraping things. All right. So let's check out this very simple HTML file that is included with the notebook. So we have here this article.html file, and on Windows, I'm going to use this type command, which is going to essentially print out the contents of this file. If you're on Mac, you're going to want to uncomment this line and comment this one out. The cat is the command for Mac machines. So if you run this, we should see here this document here. This is a very simple HTML document, and this document, let's just kind of go through this real quick. So we can see here we have an HTML tag, which we're going to get into more. We have a head tag, a title tag. Here's some text within the title tag. We have a bunch of H1, H2, and H3 tags. We have some P tags. We're going to go through each of these things in more depth, but I just want to kind of point these things out to you first so that it's kind of not the first time you're hearing it. And then we also have these attributes we're going to talk about later. When we're not scraping the value of a tag, very often we want to scrape the attribute of a tag. And we'll talk about that more later. So let's take a look at this structure here. So there's three main components that we need to be familiar with when working with HTML in the context of web scraping. I should kind of give an aside here, which is that I am not a web developer, right? Pretty much all of the experience that I have working with HTML is through web scraping. So the information that I'm sharing with you now is the information you're going to need to perform web scraping and not necessarily be like a web developer or something like that. That's obviously, you need to know a lot more about like CSS files and things like that. And so, but this is purely for web scraping and getting the data out. So we have three things that we want to talk about: the tags, the values, and the attributes. So tags are content labels that specify formatting of the elements of the page. So for example, here is a tag. This is a head tag, and then here's a title tag. And we'll see that here these tags are surrounded by these open and less than greater than signs. So these tags, sometimes they're just really used for formatting. They're used for assigning labels to the content of our page. Sometimes the tag has a meaning. I mean, they all have meanings, but sometimes they actually have a physical meaning that changes the representation of the format of the page. Sometimes they're really just, they're just placeholder kind of tags like span or div, that kind of stuff. But other times, like for example, these H1 tags and H1, H2, and H3, these are header tags. So for example, any text that's located within an H1 tag will have, I can even show you here in Markdown, will be this header 1. So it'll kind of be a very large text here. And then header 2 will be something like this. It'll be a little bit smaller. So we can change the size of our text on the page based on what tag that value is nested within. The next thing I want to talk about are values. Values are 75% of the time the thing that we're trying to extract from the web page. So a value is the string value of a tag, and it's usually what we're trying to scrape. And we know that something is a value when it's located between an open tag and a closed tag. And I'm going to talk about that more a little bit when we talk about how tags are made. So for example, here's an open tag, here's a closed tag, and here is the value of the tag, which is article. So it's a string article. If I wanted to get the value of the title tag on this particular website, it would be article. That would be the string that gets returned. Or for example, here we have a p tag. If I wanted the value of the p tag within the H1 tag, that would give me, this is the first paragraph. That's what the text that I would get back. Now, notice I said the p tag within the H1 tag, and that's because there are other p tags in the document. So I can't just say, give me the p tag value, because it would actually, depending on how you do it, it might give you back this value and this value and this value, which may or may not be what you're trying to do. But if I want to be more specific and I just want the p tag underneath H1, I am actually wrong, because this always throws me off, because these p tags aren't nested in the tag. So forget what I said that last 30 seconds. This p tag, we would just have to say the first p tag in the body tag, or the second p tag in the body tag, or the third p tag. Okay. So again, the values are really 75% of the time, 80% of the time is what we're trying to extract. And then when we get to and then we have the attributes. So an attribute is like a tag identifier. It's an attribute of a tag. And sometimes the data we want to scrape is located here. So for example, this H1 tag has an ID attribute equal to the string 1. Okay. So what I can do is, if there are multiple H1 tags on the page, I can say, I only want the H1 tag where the ID attribute is equal to the value 1. And that allows me to identify the H1 tag that I'm interested in and extract the information from just that tag. And that's going to be important later because we'll see that there could be tens, if not hundreds of the same tag on one page. And we need to have some way to say, I only want this type of, I want this tag, but I only want this little subset of those tags. And the way that I'm able to kind of filter those tags is by using attributes most of the time. Sometimes we use position also, but attribute is usually the better way to go. Now, sometimes the attribute actually does something to the text or the tag. For example, we have this A tag here, which I just highlighted, and inside that we have this href attribute. So an A tag stands for anchor tag, and that's really a hyperlink reference. So when we look at this page, this text here is the Google website will be a hyperlink reference, and the reference will be this www.google.com. And the way that changes is because we've inserted this href attribute and with some value that's a URL. And that's a way to kind of make this hyperlink reference. So you can see that sometimes the attributes will actually change the content on the page as well. So let's talk about these a little bit more. So an HTML document consists mostly of tags. These tags are labels we assign to different parts of the code to help us better organize the page structure. Like I said, the tags can have special meanings, which sometimes affect how the page looks. Some very common tags are div tags, span tags, A tags, P tags, LI tags, which I believe stands for list item. UL tags, which it usually contain, a UL tag will contain a bunch of LI tags. Table tags, TR, like table row, we're going to talk about table row today in our example. TD, table data, so like each cell in a table maybe in like on a website. So there's lots of different tags, and as you get more familiar with web scraping, you start to understand what the tags mean and kind of what to expect from the page formatting based on the tag name. I'm not really going to go into kind of what each one means right now, but that's something that you should be aware of, that the tags do have meaning, and the meaning is meant to make the formatting more straightforward of the page, I should say. So let's take a look at this this code again. And then we want to look above and we want to see the different types of tags. So here we have HTML tag, we have a head tag, we have a title tag, body tag, H1. I showed you all these. Now there's two rules about tags that we need to know. The first one is that tags are always enclosed by an open, a less than sign and a greater than sign. So these two little side carets, right? So, and the tags are always enclosed by those, okay? And that's to distinguish the tags from the page content, okay? And then the second thing is that a pair of tags consists of a start and an end tag which have the same name, except that the end tag is preceded by a /. So here's a good example. Here we have title, and then the close tag is again title, except that it's preceded by a / here. And that's saying, hey, I'm closing my open tag. This is only the stuff that I want in this title tag. It's kind of like parentheses, right? We have an open parenthesis and a closed parenthesis. Within that, we kind of close that block. Like a function call or something like that, or a list comprehension or anything like that, okay? So tags can be and are very often nested within other tags. We're going to use the tag names to specify the path to the element on the page that we're interested in scraping information from. So I like to kind of explain tags in a way where it's, I think that the best way to explain this is like a tree structure, right? We have at the top of our tree, we have our root tag, which is HTML. And then within that, we have a head tag and a body tag. And these are sibling tags because they're on the same level of our tree. And the HTML tag is the parent tag, right? It's the most direct descendants, they're direct descendants. And then within the head tag, we have a single title tag. Within the body tag, we have 6 tags with H1P, H2P, H3, and P. So if you could imagine this kind of tree, and then we kind of branch out to head and body, and then from body, we branch out to H1P, H2P, H3P, and then within one of our P tags, we actually have an A tag, okay? So the tree structure is a good way to think of it. And then another way to think of this is kind of like a file structure, like a local file system, where these tags are kind of like folders, and the values of the tag are kind of like files within the folder, okay? And so not really we're going to kind of follow this kind of folder structure, but there's another type of way to identify the path to an element on a page. And when I say element on a page, I mean like this is an element, this is an element. Any individual kind of entity on a page we can call an element. Even like this whole bar, even though there's a bunch of elements within this outer element, this outer bar element is still an element itself. So we talk about elements on the page in that way. So there's something else called an XPath, which I believe is a lot easier to work with, but we can't use that in Beautiful Soup here when we're using the HTML parser. But if you guys are familiar or want to look into more advanced scraping techniques, you can look into things like Scrapey and Selenium, which will use XPath, which I find a lot easier to work with. But Beautiful Soup gets the job done as well. So let's talk about the values. Hopefully this doesn't take too much explanation. A tag may or may not contain text. So for example, this head tag does not have a value, right? There's no text in between the head and the close tag, the open tag and the close tag that's not nested within another tag. So this title tag does have a value, right? There's a value right here. It's between the open and close tag. But the head tag does not have a value because there's no text that's outside of the title that's between the head and the open and close tag, okay? Now this H1 tag has a value. It's right here. It's called, it's 1, right? It's in between the open and close tag. And that's the key here, that the values will always be located between the open and close tag. But sometimes the tags don't have a value. That happens a lot too. The text content is known as the value of the tag. Very often this text is the data we want to scrape. And then here is just showing us that the title tag has the value article. Because this value is located in the title tag, we will see this in the tab of our browser when we open up this website, this page. So what I'm going to do is I'm going to open up this file so we can see it in a web browser. So it's a super simple file, right? This is not a super complicated website here, but we can see here, here's the H1 tag, here's the H2 tag, here's the H3 tag, here are our paragraph tags, and here is our A tag, right? This is our hyperlink reference that we were looking at before. So this is not really working, but what we're trying to do here, what I wanted to point out here is that the article, the value article is in the tab in our browser, right? And that's this tag right here that if we put the whatever value we put within the title open and close tags will be the name of the tab for in our browser. So again, just showing that, you know, based on how you format the structure of the HTML code, you know, your website will look different. That's kind of the point, right? Now, attributes are definitely important to talk about, not always because we want to get the value of the attribute as like scrape the data, although sometimes we do want to do that. But attributes are usually what's going to be your first line of attack when you are trying to identify a certain subset of tags. Your attribute is your filtering criteria a lot of the time, and it can help a lot in that way. So tags will sometimes have one or more identifying attributes that differentiate the tag from other tags on the page with the same name. So a tag doesn't need to have an attribute. Sometimes it doesn't, just a tag. Sometimes it'll have a single attribute. Sometimes it'll have many attributes, okay? And again, these attributes are used to differentiate tags of the same name from each other, right? You know, if you have a whole bunch of TD tags on the page and you want to differentiate them from different, like this TD tag up top is different from the one on the other side of the page, you can give it like a different class attribute or a different something like that, okay? And again, this will be relevant when we're looking for pattern matching later on. So the attributes are always located within the open tag and they follow a dictionary-like structure. So let's look here. So here is my ID attribute, and it's located within the open tag, right? So here's my open tag, and within that I have this ID attribute. And then I said it follows this dictionary structure where we have a key and then a value, right? So here's my key, which is my attribute name, and the value of the attribute is the actual value. So here's the 1 in this case, and then here ID equals 2, and then ID equals 3. Now this ID attribute is special because it should be unique on the page for every tag, right? So when you use ID to specify a tag that you're trying to find, you should only really ever get a single ID or a single tag returned because ID should be unique, okay? Again, here we have an href attribute, so that's located within the open A tag, the open tag for A, and then here we have, you know, the name of the tag is href and the value is google.com. All right. When we're not scraping the value of a tag like this, right? So here is the Google website, which is the text. We're very often scraping the value of an attribute, whether it's like the number of stars for a rating, or if it's an href, like a hyperlink reference, which is very common because a lot of times we want to not just scrape the page we're currently looking at, but we want to find links and then follow those links to other pages and scrape information from those subsequent pages, right? And so if we're able to, for example, find all the hyperlink references on a page for like maybe a whole bunch of businesses on Yelp or something, and we want to visit each business page, we can scrape each of the hrefs from those A tags and then get and then visit those individually and then scrape maybe data from each of those individual pages. So many times, if we're, you know, most of the time, if we're not scraping this, then or the value, then we're going to be scraping some sort of attribute. And I would say that makes up 98% of the scraping you'll be doing. There are some other ways that we can kind of make Boolean values and things like that from whether or not a tag exists and things like that. But for the most part, it's going to be the value of the tag and the attribute is what you're looking at to scrape. I made a short note here, which is don't confuse tag values with attribute values. So this is the tag value, right? It's the string located between the open and closed tag. This is the attribute value, right? And I'm going to be using the word value to describe both, but I want to make that very clear that when I'm saying tag value, that's the text located in between the open and closed tag. When I say attribute value, that's the value of the key, the attribute key that we're talking about, okay? All right. So let's talk about Beautiful Soup and why we're using it. So Beautiful Soup is a library that contains tools that makes it easier for us to parse out data we want to scrape from different types of web documents. Today, we're going to be using the HTML parsing capabilities, but there's also a parser for XML. So we can import Beautiful Soup using this line here. So I'm going to say from BS4, we're going to import Beautiful Soup. And Beautiful Soup is a class now, okay? And this class is going to, this constructor is going to make an object from text. We're going to pass a whole bunch of text. And if you guess that the text is going to be the source code for the HTML page, then you were right. We're going to take this HTML source code and we're going to parse it so that it's much easier for us to find certain tags on a page or find the value of a tag or the attributes and things like that. And Beautiful Soup makes it very simple for us, which is really nice. Now, this Beautiful Soup constructor, this class here, takes two arguments that we're interested in or that we need to kind of point out here. The first argument is the source code that we're trying to parse. The second argument is the parser type, right? So which parser we're going to use. So what I'm going to do here is I'm going to open up my my article.html file in read mode, and then I'm going to read that as a long string. And just to prove that this is a long string, let's run this and kind of print out what it is. So here we can see, here's my long string that I've read in from my file here. And then I'm going to make this article object, which is made from the constructor, Beautiful Soup. I'm passing that long string as text to my Beautiful Soup constructor, and then the HTML parser, which is what we're going to use to parse the HTML. And once I've done that, I can just print out or return the value of this article object. And we can see that we have, it kind of looks very similar to up here, except it's not really indented nicely, which is okay. And then also, I just want to show the type of this article thing, and we can see it's a Beautiful Soup object. Something else that's kind of useful sometimes, although I don't use it too often, is this prettify method. So the Beautiful Soup object has a prettify method, which is going to format our Beautiful Soup object so that it prints out the source code where the open tag and the close tag are kind of sandwiched on above and below the value of the tag. It's supposed to make it easier to read, but I rarely use this because we're not going to be working with source code that's like 10 lines long. It's usually going to be hundreds, if not thousands of lines long. So this is really not super useful, but it's just interesting to see this. All right. So it doesn't look very different from what we printed out on the source code, but there's a number of tools that are available to us that weren't available when the document was in a string format, okay? So the three things that really are very interesting to us are the name of the tag, the string or value of the tag, and the attributes of the tag, okay? So the corresponding attributes of this Beautiful Soup object are name, string, and ATTRS, or attributes, okay? So for example, from article, we can extract the H1, or we could say, I want the H1 tag. And this, by the way, is only going to give us the first H1 tag that it encounters in the hierarchy of the document. Although, because we only have a single H1 tag in our text document or in our file here, it doesn't really make a difference. But once we've done this, we can see here, and I just want to show what this is, we have this H1 tag that we're able to kind of extract just by saying .h1, and that gives us the tag name, or the tag object, okay? Now, if I look at this, the type of this is actually a tag type object. So this is a special tag class that belongs to the Beautiful Soup library, okay? And this object has a bunch of methods that are associated with it. We're going to talk about later, but some of them are the name, string, and attributes, which are attributes of this object, okay? Now, the name attribute just gives us back the name of the tag. So in this case, it's an H1 tag, so the name of the tag is H1. String is what's going to give us the value of the tag. So this is something that you guys should be very familiar with after you've been scraping for a while, because this is generally what you're going to be using to extract the text value from the tag. And then ATTRS is a dictionary that contains all of the attributes of the tag in key value format. Okay, so it's a dictionary. So if I print this out, we can see that the name of the tag is H1, the value of the tag of the H1 tag is 1, and then the attributes of the H1 tag are ID and 1. And we can see here that here's my H1 tag. My ID attribute is equal to 1, so that's the only attribute. So my dictionary only has one key value pair in it. And then here's my 1 value, which is right here. So using these attributes to extract the data from the tag only works when we're interested in inspecting the first and most direct child of the current tag. Okay, so what do I mean by that? Well, what I mean is that when we look, let me do cat. Oops. So what I'm saying here is that, like I said, if we say article.h1, it's going to give us the first h1 tag it encounters in this document, okay? So if I had multiple h1 tags and I said article.h1, it's not going to return a list of h1 tags. It's just going to give me the first one. If we want to get a list of all of those h1 tags, we have to use something else, which we're going to talk about. So that's kind of, the simple introduction here. We have name, string, and attributes. These are going to be very relevant going forward. So now we have two things called the get text and the get methods. For tags that don't have a value directly within it, like for example, that head tag or that HTML tag, the string attribute doesn't work as we expect. So for example, this HTML tag, if we look up here, HTML has no value directly between the open and close tag, right? All the values are somewhere within these other tags. So there really is no value of the HTML tag. There's no string value that's associated with that. So when we do article.html.string, we're going to get a none type back because there is no string. There's no value of that tag. However, if we just want to get all the text, all the values that exist, either of the current tag or any of the child tags, or those childs, and then so on, what you can use is the get text method on the tag. Okay, and in this case, we can see here we have this article.html, and then we call get text, and that's going to return all of the text from every child tag all the way down the line to the very bottom. Okay, so we can see here that in this HTML tag we have this value here, we have this value here, we have this one here, we have this one here, we have this one here, and then so on, right? So it's going to print out all of those for us, and then also some like new line characters and things like that. So we'd have to probably trim this up a little bit, but this is how we can get all of the text within not only the current tag but also the descendant tags of that parent tag. The get method is used to extract the value of a specific attribute of a tag. Okay, so if we want to get the href attribute value from an a tag, we can use this code. So here we have article.a, and again, we only have a single a tag in this whole HTML document. So we can just say article.a. We don't have to worry about finding a specific one or anything like that. But let's say we want to get this URL here because I want to visit that and then scrape what's on that page. What I can do is I can say article.a and then .get href. And that's going to return the value of the href attribute for this tag that we're calling the get method on. Okay. Now, this is the same exact thing as just saying a.attributes and then using dictionary key lookup to find the href attribute from that tag, or from that tag. And so this is just another way of doing that. Either way is fine. Get kind of skips a couple steps. It's a little bit easier, and you should recognize get if you've worked with dictionaries before, because this is a popular dictionary method that we can use to get the result or get the value of a key. So that's the get text and get methods. Hopefully those are pretty straightforward. Now we're going to get into some more stuff here, which is the find and find all. So I mentioned before that if we use the beautiful soup object tag name, that's only going to give us that first tag that it encounters on the page. But many times we want to get a list of tags that match some certain criteria. Like for example, let's run to our example for later, just to give an example of what I'm talking about. So we're going to scrape this later. This is the movies that have been released this year so far, and the top best movies based on their Metacritic score. We'll talk about this a little bit later. But we can see here that I have like this element here, which is like this piece, and then we have here's another piece, and here's another piece. So it's very often that I want to get a whole bunch of tags that match some criteria. In this case, I want to get all of these TR tags that I'm looking at here, and we're going to talk about this in more depth later. But this is I want to get all of them So I have them in a nice, neat list, and then I can iterate over the list using like a for loop or something, or a list comprehension, and then extract different pieces from each one individually, okay? So it's a lot easier to narrow, instead of saying, for example, I just want to get all of the titles from everything in this block here. So I have an element here, which is this table. And then it's a lot easier to get the TR tags separately and then iterate over them and look at them separately. It makes it a lot easier. So because that's the case, we can use these find and find all methods, which allows us to be more specific with what tags we are extracting or finding. Okay. So for example, we might want to find all the LI tags on the page that share a class attribute with a value of review. Let me just show that example again, because maybe this will be a little bit more straightforward here. Or let me show this this one here. This is a good example. So these are some Python events. And we can see here, I have this this UL tag with class equal to list recent events menu. And I can see here that both of these are both tables here, kind of like these UL tags, and they contain all the events that I'm interested in. So maybe I want to get all the UL tags where the class attribute is equal to list recent events menu. And that would give me this UL tag, and it would give me this UL tag, and that contains all of the information that I want to scrape. In this case, I would want to scrape like the event title and where it's located and the time and things like that. So using these attribute values as a filtering criteria to only get, you know, these specific UL tags. Maybe there's a whole bunch of UL tags on the page. In fact, I can just check, and in this case, there's 28 UL tags on the page, and that's not what I want. I want only the ones that I'm interested in looking at. So I can use the attribute value as a way to filter which tags I'm looking for. So in this case here, so let's just back to this example here. Let's say I want all the LI tags on the page that share a class attribute with a value of review. So if I wanted that, I would use, from my beautiful soup object, I use the find all method. My tag name is LI, and then I pass a dictionary to the attributes argument, and the dictionary contains a key and value, which is the attribute and the value that I want these tags to hold. Okay. And this will match all the LI tags with the class attribute equal to review. That would give me a list, something called a result set, actually, we're going to talk about it a little bit, that has all these tag elements that have all of those LI tags that I'm interested in. Something that's important to point out here is that we use the find method when we know that we only want to return a single tag. Like, for example, if I want to return the number of reviews on a page, or if I just know for a fact that I'm only looking for one single thing that's not going to be like a match of multiple things on the page. We use the find all method when we know that there are 2 or more tags returned for a certain set of match criteria. For example, for those Python user group calendar, I know there's multiple events or multiple UL tags on the page. I'd use find all instead of find. If I used find, I would only get the first one matching, the search criteria. If I use find all, it's going to return all of the things, all of the tags that match the search criteria. So let's take a look at our article.html file again. We want to find the first p tag in the source code. We can use the tag attribute syntax from before. So here we have article.p, and that will give us that first p tag, which is this is the first paragraph, which is good. If we use the find method on the article object, we will also only get the first p tag. So here we do article.find, and then we pass a string p that's the name of the tag we're looking for. Now, if we want all of the p tags, we have to use the find all method. So here we can do article.find all and then pass p, and notice that we get now this thing that looks like a list of tag elements here. Okay, so now we've gotten all 3 p tags because they're, you know, the find and attribute notation here are going to only give us the first tag that it encounters with that match. Something I want to point out here is that this is not a list. Okay, it's something called a result set. Now, this is a subclass. So this result set thing is a subclass of the list class, right? So this inherits from, so a lot of the things we can do with lists, or pretty much all the things we can do with lists, we can do with result set also. But result set is really meant for holding tag objects. So it's a special type of object in in Beautiful Soup. But you can think of it as like a list. We can append to it. We can subscript to index into it, things like that. We can slice it. We can do all that stuff. We can iterate over it. It's an iterable, right? So you can think of it like a list, but it really isn't a list. Okay, so I just want to make sure that everyone knows this is not a list, but we can act like it is. To find tags with specific attributes, we can pass a dictionary to the attributes argument, where each key is the attribute name that we want to match, and each value is the value for that attribute. So here we have this article .find all, and we want to find all the H1 tags in our document where the attributes dictionary, the ID attribute is equal to 1, right? Now, we only have one H1 tag in the entire page. And again, if we're searching by ID attribute, we should only get a single tag back regardless of how many there are, because this should be unique on the page. But we can use this find all, and we can see here that we get back a result set of just a single element, which is this H1 tag that has the ID attribute equal to 1. So passing this dictionary here to the attributes argument is a very useful way of filtering, not only based on the name of the tag, but also the attribute values. Something else we can do is we can pass a Boolean function to the find or find all methods. And what it's going to do, this Boolean function, is the argument that it takes is it's going to be a tag object. And what this function is going to do, in this case, this function is going to take every single tag in the HTML document from wherever we left off. For our article, it'll be the full document. And so for every tagged object that's been parsed in that article Beautiful Soup object, we're going to do tag.getID and checking to see if that's equal to 1. So we're going to check every tag and see if the ID, first of all, if it has an ID attribute, and if it doesn't, if it's equal to 1. And this will only return tags where this Boolean expression here is true. Okay, so this needs to be a Boolean function, meaning it returns true or false, and the argument here is every tag that gets passed to this function here. Okay, so this is a tag object, which is why I called it tag. So here I'm trying to find the H1 tag, and I know that it has an ID attribute of 1, so I can say find the tag in the HTML source code that has an ID attribute equal to 1, and that's going to give us that one tag. Now I used find here because I know I'm searching by ID, so I should only get a single thing back. But I could put find all here, and it would just give me a result set of a single element. But I'm going to leave it as find for now. Now this one's a little bit trickier, but if you guys haven't worked with regular expressions, this is going to be a little bit strange, but I'll explain it. So we can find all the header tags, okay? So I know that all the header tags are going to be the letter H followed by some number, like a single digit. And it's going to be 1 through 6, I believe, okay? Now, what we can do is we can use the regular expression module to use this function called search. And what regular expressions are essentially patterns that we use to match text. So for example, this here is going to match any string that has an H followed by a digit, and D means digit. I can also do 1 through 6 here, because if I know that I'm only going to have either 1, 2, 3, 4, 5, or 6, maybe there's like an H9 that's not really a header tag, it's something else. Maybe I don't want to include that, so I can also use this as well. This, and then this is my tag.name is going to be the name of the tag that I'm passing to my function here. Okay, so this is going to return either a none type, or if it can't find this match in my current string, or it's going to return something that's not none. Okay, and so if this is not none, that's essentially a true, right? If it's non-empty, then it's going to be a true, which means that we found some tag that has an H1, an H2, an H3, an H4, an H5, or an H6. So if I run this, we'll get back all of my header tags in my document. So I can use this find all and then pass this Boolean function, which I'm using a regular expression to determine whether or not something is matching or not. Okay. Now, I at first had done something like this where I said, let's just let me write this again. Well, instead of using regular expressions, let's do something else. So let's do, let's say tag.name, the first element of tag.name, right? So remember, tag.name is a string. It's going to be the name of the tag, so P or div or H1, H2, H3, right? These are all names. So and then I can subscript and get the first element of that string, which will be a character, and we want to see if it's equal to H. Okay. Now, if I do that, unfortunately, I'm going to get back the HTML tag. I'm going to get the head tag, right? I'm going to get all this stuff, which is not necessarily what I want, because I only want the header tag. So which is why I implemented this other regular expression method, which is going to only get our header tags. So it's important to think about what your logic is for filtering using these Boolean expressions, these Boolean functions, because it can really make a difference of what tags are being returned. And a lot of times, the thing that you get returned, the result set, is very large, like thousands of elements sometimes. And so it's not really realistic to go through and kind of see that you're not getting the right stuff. But it's important to implement testing and debugging in your code to make sure that everything you're getting is really what you expect. And if there are edge cases or exceptions to the rule, things like that, then you need to handle them on a one-on-one basis. And we'll talk about that a little bit more later. All right, so let's kind of bring everything together that we've learned so far, and talk about what we're actually working with here. Okay, so the last thing we should notice is the find method returns a tag object, and the find all method returns a result set object. So we talked about result set. It's very similar to a list, except it just has tag objects, and it is iterable, which means I can say for element in result set object, and then I can iterate over that result set, or I can use list comprehension, things like that. A tag object is an instance of the tag class from Beautiful Soup that gives us access to attributes name, string, attributes, and the methods get, text, get, find, and find all. So everything we talked about, we call those things on tag objects, like article.p or article.h1 or article.head or whatever it happens to be. So we can the tag object allows us to use these methods so we can either extract information from the current tag or look deeper to find child tags like descendant tags that might have information we're interested in. So for example, here, this is just showing us the type of these two different things, which is totally fine. For example, if we want to find the value of the tag returned by the find method above, we would use this. So here we have article.find, the tag where the ID attribute is equal to 1. This returns some tag object, hopefully, unless it returns none. And then I want to get the value of that. So I do .string, and that's going to return 1, right? And this is my data, right? This is my end product. This is what I want to store in a structured format so I can go ahead and save it to a CSV or something. And then similarly here, we have all of our H1 tags, or I'm sorry, our header tags, right? So this find all method that we showed above is going to return a result set of H1 tags, or not H1, but 8 header tags, I should say. Now, I can't do .string on this result set, but what I can do is I can iterate over it using a list comprehension. So for every tag in my H tags thing, this is my H tags, which is that result set. For every tag in my H tags, I'm going to do tag.string. And that's going to extract the value for each of those. And so I can go ahead and get the values of each of my header tags. So that's a way to go ahead and get this data when we want to extract it. So it's important to make that connection between, finding the tag objects and finding the objects that we're interested in, and then extracting the information that we want. We want to, the full process is going from the, step 1 to step 2, and then we get to the final data. All right, we're almost where we need to be to start the web scraping example. So the last thing I want to talk about here is the request library. So in the examples above, we use the local HTML file. And that's actually located right here in the data folder. We have this article HTML file. And then we're just reading that file into our Python environment as a long string, okay? Now, normally in practice, we're not going to download the source code for every single page manually and then read them in as like a text file, because that would just be kind of a lot of code that is kind of annoying, and we have to store the file somewhere and things like that. So the request library is going to handle that for us. It's going to handle the downloading to make it a lot easier to access source code without having to download the source file and then read it back in. So it's well designed and very popular in the industry for downloading HTML source code for websites, and it makes HTTP requests easy to use in Python. So within the request library, we have this get function, which is going to allow us to make a type of HTTP request, which is called the GET request. If you guys are familiar with this networking and things like that, there's a bunch of different HTTP methods. The most popular are the GET and the POST. So GET is when you request from the data from the server, meaning like, hey, I want to visit Google, please give me the Google source code so it will render on my browser, right? That's a GET request. A POST request is when you're submitting information like you're putting in credentials to log in, you're uploading a file, things like that. That's a POST request. You're sending data to the server. Those are pretty much the most common ones, but we're going to only be working with GET because we want to get, essentially when you call a GET request, it's like you're putting an address into the address bar up here and you're clicking enter and you're getting the contents from the server. So we're going to import the request library, and then we're going to use this request.get method function, okay? And this function is going to take one argument right now, which is the URL that we want to get the response from, okay? Now I call this object here response that we save the return of this get function from. And that's because when we make a get response, we get a response from the server, and that response is going to contain things like the status code of our request. It's going to return the source code of the page. It's going to return a whole bunch of other metadata and stuff like that. But we store it in something called a response. One of the things in this response is this attribute called text, and that is the actual source code, which is what we want. So this is kind of like what we did before, where we read the file into a long string as a long string, and then we pass that string into our beautiful soup constructor. Here, we're getting a response object from this get request here, and then from the response object, we have this text attribute. This is the long string that has our source code. Okay, so I'm going to make this text object from this Python events calendar, and you can see here that now we're really cooking. We're cooking with gas here. So this is a lot longer than our example, and this is a lot more like what you're going to be using in practice. You're not going to be working with a file that's like 10 lines long. It's usually going to be something long like this, which is why I said that prettify method is not super useful, because even if I do prettify here, I'm not going to be combing through this. Doesn't really make sense. So if I prettify this, it's not, I mean, I guess it kind of indents it for me, but it's not super useful. I'm not going to be combing through this manually. All right, now there's two things we want to talk about here. There's the status code and the text, okay? So the status code is 200 in this case. That's good. We're going to talk about that in a second. And then the source code is right here, which is super long, okay? So this is really long. It's much more complicated than the local example we use. Hopefully this is showing you how nice the beautiful soup library is, because it's parsing this information, this large amount of text, much easier. It makes it much easier for us to work with. Now we need to talk about status code here, because the status code is telling you whether or not the request was successful, okay? A 200 status code, or pretty much anything in the 200 range, so 201, 202, 203, anything in 200, but usually 200 means that we're A-okay, everything went through correctly. If you get something else, you might have an issue accessing the elements of the page. And here's more information about different status codes, so we can see information responses, successful responses. We usually want to see 200. We have redirects, which sometimes can be okay. So if you see a 300, that's usually okay. And then we have client errors and server errors. So if you see a 400 status code, that usually means that the website doesn't exist, or you don't have access to it, or something like that. You don't have the right credentials. 500 status codes are server errors, which is really, you can't really do much. It's like the server is down or something. Now, let's try a different example here, where I'm trying to go to Metacritic, which is what we're going to scrape later. So I'm getting the response from Metacritic, and then I'm going to print out what the status code is that I get. Now, notice I get a status code of 403. That's a problem, because status of 403 is bad. That's usually, I'm sure you guys have seen this, where you go to a page and it says 403 forbidden on the top of the page. That means that you're getting, your server is refusing to give you access to the site, because we look like a robot, essentially, okay? So let's check out the source code we get from this request. I think can we mute that buzzing sound?
Yes, I just did.
Thank you. For the response.txt here, we can see that we have this source code is not at all what we would expect to be looking at, right? And the reason I'm pointing this out is because I can't tell you how many times I've been working on a project and I've been trying to work on my tag search criteria, and I'm not getting anything, and it's driving me crazy, and I don't know why. And then I look and I see that my source code looks something like this. Okay, this is not the source code for this page. This is the source code for a page that says 403 forbidden. You can't have access to this site. So naturally, the elements on this page are going to be different from the ones that we were looking for. So I'm not going to find this element in this source code because this is a totally different page. Okay, so that's why it's very important that we check the status code, because if we don't have the right status code, and we're probably not getting the right source code back, which means that there might be a disconnect between the elements on the page we're looking at and the elements in the source code that we've downloaded. So make sure to always check your status code. Now, how do we get around this 403 error? Well, there's something we can do, which is called adding a headers argument to our get function. The headers argument is a dictionary that has one key it can have multiple keys, but the only key that we're really interested in is something called the user agent. Okay, the user agent is essentially an identifier for your system software. Okay, so for example, if I'm viewing a page like a website on a Windows PC using Mozilla Firefox, then the server is going to need to send different source code than if you're viewing a page on some Android mobile device using Google Chrome, right? Based on the operating system and the software you're using, the browser you're using, the source code needs to be changed so that it fits your browser, things like that. It's nicely formatted. So you need to, the user agent is that identifier. It tells you what software you're using and what operating system you're using, essentially, okay? Now, why this is important is because if we pass this to our get function, it's going to kind of tell the server, hey, I'm not a bot. I'm actually like a user with this identifier, this user agent, and please let me have access to your site, right? And so it's going to, essentially, it's a way to trick the server into saying, I'm just a normal user. I'm just visiting your site. I'm not a bot. Please give me the source code. And so this user agent generally can fix a lot of those problems where you don't get access to the site if you just pass the URL by itself. I have my user agent here, but you guys should all put in your own user agent, which will change based on the version of Chrome you're using or Mozilla or whatever version operating system you're using. So all you have to do is just go to Google and search what is my user agent, and it'll show up right here. And you just copy the string and then paste it as the value for this in this dictionary here. So when I run this now that I've done this, we can see my status code is 200, which means we have access to the site. Now our, let's look at response.txt. There is our source code, which looks it's a lot bigger, which means that it probably has a lot of content on the page, which is what we want. All right, so it is 304, 305. We have the example left, which I'm definitely going to go over. If you guys can stay and hang out and follow this example with me, that's great. If not, you can watch the recording. This will be available to everyone. I also want to give a brief some time for questions at the end as well. So hang around if you're interested in that. Does anyone have any questions before I move on to the Metacritic example? Are there any advantages of Beautiful Soup over Selenium? Does Beautiful Soup support switching iframe context? That's a great question. So for those of you who aren't familiar, Selenium is another web scraping framework, which essentially is much better at scraping websites that have dynamically updating elements on them. So for example, if you've ever been on a site where it's infinite scroll, where you scroll down and then more elements load and more elements load, those elements are not located in the source code until you actually do make the trigger to scroll down. So when we download the source code in Beautiful Soup, those additional elements won't exist because we haven't actually scrolled on the page, right? So Selenium will actually launch a Chrome driver or some other kind of driver. It'll essentially launch a web browser and will allow you to interact with the site, and just like you would like right now, for example, like I can do this, I can click on things, I can scroll down, all that stuff. The problem with Beautiful Soup is, the problem with Selenium is that it can be very slow, okay? And the reason it's slow is because you're actually launching a web browser, and then the images on the browser, in the browser on the page, you need to render, which can take a couple seconds. And every second that you add, if you're scraping 1,000 or 100,000, I mean 100,000 a lot, but if you're scraping 20,000 pages, adding a second to every page makes a big difference, right? So Beautiful Soup, because we're just downloading the source code and parsing the source code, it's a lot faster. And same with Scrapey also. And Scrapey is even faster because it can do things in parallel. So Scrapey is a really I like Scrapey a lot. That's usually my go-to if I don't have to use Selenium. The disadvantage of using Beautiful Soup or Scrapey is that you cannot generally access things like iframes or embedded elements on the page. Sometimes iframes will have like external links that you can visit and then scrape the stuff on that page. But if there's anything interactive on the page, like clicking next and the URL doesn't change, or scrolling down, or anything like that, or like pop-up kind of elements, things like that, you're going to have to use Selenium. Or there's also something called Scrapey Splash, which allows scraping the pages with Ajax, which is that dynamically updating elements. Good question. Can you run Selenium or Beautiful Soup via Docker container? Yeah, absolutely. I don't see why not. I have, as long as you have the packages installed and you have a good internet connection, Selenium, depending on what, Selenium will actually need a browser installed. So you need to have an operating system that has, so you're saying without a GUI, so terminal only. Beautiful Soup will work. Selenium will not work that I know of. There might be a way to get around using Selenium in a terminal only, but I'm not 100% sure. I'd have to look into that. But Beautiful Soup for sure, and Scrapey as well. In fact, I have not in a Docker container, but it's a Raspberry Pi, which is essentially a Linux. It's Linux or Unix environment, I should say. So I have a daily scraper that's scraping some stock information. So that's definitely doable, and it happens all the time, and it's definitely something that you can do. All right, so let's go ahead and look at this Metacritic example. So Metacritic, if you guys aren't familiar with it, it's this media review site. They review things like games, movies, TV, and music. I usually use it a lot for games, but it's kind of like Rotten Tomatoes, but for a different variety of things, right? So Metacritic has this thing called a Metascore, which is kind of this aggregated score for they take a whole bunch of different critic reviews and they weight them in different ways, and they take the average, the weighted average of the reviews, and then they get this Metascore that's usually pretty reliable. Looks like Tom and Jerry movie didn't do too well, unfortunately. Some other stuff going on here. So what we're going to do is we're going to scrape the top 100 movies of 2021 so far. Okay, and we're going to scrape a few different things. We're going to get the title. We're going to get things like the release date and then the rating. We're going to get the Metascore, and I believe that's it. Now, in this case, notice there's this expand thing here, right? This expand collapse. If we wanted to get, for example, the description here, let me actually just check. Actually, this description is available even though we don't click expand. So we can actually, sometimes we can actually access elements, even though they look like they're contracted, we can actually access the element in the source code without having to click this expand. But for example, if we wanted the user score, I think maybe we'd have to, let's see what happens. No, the user score is still here too. So we can actually get the user score as well if we wanted to do that. So in this case, it doesn't look like we'd have to use Selenium, but there are cases where we'd have to click these expand buttons for all of these before we can collect the data that's hidden in this section. All right, so this is what we're looking to scrape. I'm going to go through these tools in a second. So first, let's get the HTML source code and create a Beautiful Soup object. So here's my headers. I should mention, by the way, just to kind of put a pin in this, or just to kind of finish this this sentiment here. We have our headers object is a dictionary where the key is user agent and the value is our user agent value, right? And so that's just a single key value pair, and then we pass that to our get function as headers. So we say headers equal to headers, and that's how we pass in our user agent to our get request. So we're going to get this response object, and then we're going to check out the status code, and then we're going to create this Metacritic object, which is the beautiful soup object using the response.txt and the HTML parser. So we got a status code of 200. We look good. I can uncomment this and kind of look at our source code. It looks good to me. It's super long. And we can see there's so much stuff here. So it's kind of crazy to go through. But it's good that it's here. So I'm just going to comment this out and run it again so we don't have this huge, super long thing. Okay. So let's figure out where we're going to start. The first part of a scraping project is really what are the fields that I want to what are the fields that I want to extract, right? That's really what I want to get here. And so in this case, like I said, we're going to get the title, we're going to get the meta score, we're going to get the release date, and we're going to get the rating of the movie. Okay. Now, on this page, we see I have 100 movies. So here's my 100 movies, and then there's also another page, but we're just going to do the first page in this case. What I want to find now is I want to find the tag for these elements, meaning these elements here that contain all the information that I want. Because what I really want to do is get these tags and then iterate over each one. And then for each tag, I want to say, all right, give me the title, the meta score, the release date and the rating, and then store that and then write it to a CSV file and then go on to the next one, right? We don't want to say, give me all the titles on the page all at once as a list, and then give me all the meta scores on the page, and then give me all the release dates on the page. We'd really rather like to do it in these little kind of packaged items where each item contains all the information for a certain row in like a CSV file, for example, okay? So, and the reason why is because if any of these have like missing values, maybe like, there's a problem with, this, we'll see that actually some of these don't have ratings, but we don't want there to be missing values that aren't synced up with the correct movie. So for example, like if we have 100 movies and we have 100 movie titles, but we only have 97 release dates, how do we know which release date goes to which movie, right? So if we look at each tag individually, we're kind of narrowing our scope and saying only look at the tags within this parent tag, and that way we're looking at all the information for a single movie at one time, and then go forward. Okay. All right. So let's look at our inspect tool. So I showed this before. Let me show it again. We can either press F12 or we can right-click on our browser and click Inspect. And that will pull up this, this panel here, which is super useful for finding tags on a page or finding these paths to our elements here. So like I said, what I want is I want like this kind of thing here that has all my data. So I want to find the tag that represents that. So I can, in the top left here, there's this element inspector tool. If I click on that, I can kind of hover over here and find something that contains all of my my elements here. Now, what I really want is this, really, because this contains all that, you can see it contains all the information that I want to extract here. So I'm going to start from this level, and we can see that this is a TD tag with class equal to clamp summary wrap. So let me see. I'm just going to do a quick search here, which I can do by doing Control F in this box here. But this is something called XPath, and XPath is like I said, the kind of the path to the tag name. But we're not going to be using that in Beautiful Soup. We use that in Scraping and Selenium. But I just wanted to see if there are 100 of these, because if there are, then I know that I've gotten all of them on my page. And in this case, actually, I have kind of a more roundabout way of getting to where we want to get. But it looks like we can actually just do the TR tags here, or the TD with class clamp summary wrap or something. So let's just double check that one more time. Clamp summary wrap. I'm going to triple click here. So we have a TD tag here with class attribute equal to clamp summary wrap. So let me see what happens when I try to extract that. I'm just put it in here for now. So I'm going to say Metacritic dot find all. I want all the TD tags where the class attribute is equal to this clamp summary wrap thing. I'm going to get a whole bunch of stuff back here, and I really just want to look at the length of this, right? Because if this gives me back 100 things, then I know I'm on the right track, because that means that I know there's 100 movies, and there should be 100 of these TD tags that contain the information that I want, right? So it's important that the length of your result sets match the length of the elements. If I had gotten 95 TD tags, then I know I'd be missing 5. Or if I'd gotten 105, I know that I'd be having some other stuff in here that is not appropriate, right? So it's really useful. It's actually really nice that we can do this and that it matched correctly. So what I'm going to do actually is I'm going to skip all of this because I'm going to have to amend this. But if you guys want to follow this on your own, this is another way of getting the tags. And there's some tricks here. For example, I'm finding all the table tags because you can see actually that, I don't know if you guys can see this, but there's this double line here. This is one table above, and then this next 5 movies is another table, I think. And then this next 5 movies is another table. So we have a whole bunch of these different table tags, I think. And then within those, we have to get the TR tags, which stand for table row, and then within those we have to only get the TD tags that have this clamp summary wrap thing. Okay. So you can go ahead and follow this if you want, but right now it looks like that we can just use the TD tag way, which I'm going to do just for the sake of time. So I'm going to skip down here, and I'm going to say. So those are my TD tags, and I've skipped all this stuff. I do want to mention one thing really quickly, just for anyone who likes some Python tricks. This is a really neat way of flattening a two-dimensional list. So let's say I have a list here that is that looks like this. And I really just want all these elements to be in a flat list. Like I don't want this nested structure like this. I want just to be a single one-dimensional list that has 9 elements, right? What I can do is I can call the sum function and then pass 2 arguments. The first argument is my nested list, and the second argument is an empty list. And this will actually flatten my list for me, which is really useful. And I did that here because I had a nested list of tag objects, and I just wanted one flat list of TR tags, so I ended up doing that there. But just kind of just an interesting thing here hopefully you can use in your work. All right, so here are my TD tags. Now that we have these TD tags here, which is again this part, right? It's this part here. So this is my TD tag. This is the current scope that we're at. Okay. Now for each of these, what I want to do is I want to find the title, the Metascore, the release date, and the movie rating. Now, what I like to do in a good practice is to just take the first of the tags and then try out a bunch of different, searching or code and beautiful soup syntax to see if we can get the correct values out. And then hopefully, if those are right, then we can apply those to every other tag in like a for loop, and we can kind of make our process a lot simpler. So let's first just call this one thing TD. That's going to be our first movie from our list of TD tags that I have here. And we're going to try on this one movie just to see if we can get the correct information. So the first thing is the title. So I'm going to use my inspector tool here. We're going to go and I'm going to click on the title. And I can see here that it's the H3 tag. It's the value of the H3 tag, right? So here's my value. Here's my H3 tag. And luckily, I can see, I don't think there are any other H3 tags here. It looks like this is the largest text, and maybe like this one, but it's not really. This is kind of inside some other formatting. So this, I know that I'm pretty safe to just use H3 and not have to specify an attribute or something like that. Even though there is no attribute here, I would have to, for example, say, give me the A tag where the class equal the title, and then give me the H3 tag underneath that, and give me the value from that. If I need to be more specific about which H3 I was talking about, I would just go to the parent tag, get that tag that has more, a little bit more specificity to it, and then get the H3 that's beneath that specific tag. But in this case, we can just use H3 because I know that there's no other H3 tags in this context of this one movie. So I'm going to use this find method, and I want to find the H3 tag within the TD tag, and then I want to extract the value, right? So I use string here, and that will extract my movie title. Okay, so we've successfully web scraped this. Well, actually, this up here would be really the first web scraping we've done, but now we've actually extracted value from our first movie. The next thing is the Metascore. So let's go here and use my tool. I'm going to go to Metascore. So it looks like we have this div tag with class Metascore W large movie positive and then number 97. So 97 is our value we're trying to extract. So we want to get that. Now, there's something I want to point out here, which is that you could say, give me the div tag where class equals Metascore W large movie positive. But notice that this attribute here has the word positive in it. Okay. Now that should kind of set you thinking, is this going to be the same attribute for movies that are bad or, poorly rated movies? And we can actually scroll down and test that. We can see that there are some movies here that are in this kind of yellow range. And if we look at that, we can see large movie mixed. Okay. So we can't use the exact class attribute value here because some of them have positive here, some of them have mixed, and I'm assuming some of them have negative, right? If there's a red movie or something, we can even just double check here. If there's any, there's some red ones. So here, movie negative, right? Now, what do these all share? Well, they all start with Metascore _ W. So what we can say is, I want all the div tags that have a class attribute that contains the substring Metascore _ W. How would we write that in Python? Well, we could use the find method. And remember, we're using find here because we only have a single Metascore per movie, and we're only looking at a single movie here, right? So I'm going to pass a Boolean function, and my Boolean function here is this anonymous function. I'm looking for tags that have the name div, so I'm looking for div tags, and I want the Metascore _ W. I want the substring to be in my class attribute, right? Now I can also use get here. It doesn't really matter, either one. So this is going to return the value of the class attribute. Either it's none or it's a string, right? And this there. And if this Metascore W is a substring of that, or exists in that full attribute, then we can keep that. Okay. And then we want the string from that return, the tag that we get returned from that. Okay. So again, this is going to match not only the positive movies and the mixed movies, but also the negative movies. And so you should pay attention to the value of the attribute, because sometimes you'll see that the value of the attribute will change based on the value that it's representing. And you don't want, like, for example, in this case, maybe it's changing the color of the box, right? Positive is green, mixed is yellow, and negative is red. So you need to be more flexible with how you script, because we want all the Metascores, no matter if they're positive, mixed, or negative, but we need to be more flexible with our code here to make sure we match all of those. And then here is the 97. Now, this is a string, and I should point out that every piece of data that you extract from web scraping is going to be in string format. All this stuff is in strings. So even though it looks like this is a number here, and it looks like a number when we look here, these are all strings. Okay, so we probably want to convert this Metascore to an integer, because we'll use it for analysis later. So we could do like average Metascore, things like that per different groups or something like that. So we can go ahead and convert this to an integer, and now we can save it correctly. All right, now let's get the release date information. So let's go back here, and we can use our tool here. I'm going to go here and click on this part, and we can see here that there's actually this div tag with class attribute equal to clamp details, and then there's a span tag with the date, and there's a span tag with the rating, with this pipe thing. Okay, now all of this data is located underneath this clamp details div tag. So what I can do is I can say, give me the div tag with class attribute equal to clamp details, and then I can use the get text method, which will return both of these texts, these strings together, and then I can maybe split it on this pipe, and then I can get the two values, right? So this is a little bit easier, because I would have to say, give me the first span tag in this div tag, and then give me the second span tag in this div tag. But it might be easier just to say, give me the div tag and give me all the text there, and then I can use base Python string methods to extract the data I want. So that's exactly what I'm going to do here. I'm going to find the div tag where the attribute class is equal to clamp details, and then I'm going to use get text. And now we can see that we have this, new line character, and then here's our date, and then new line character, and then some spaces, and then a pipe, and then a space, approved, and then new line character. So I need to now use base Python to use string methods to extract the pieces that I want. What I'm going to do here is I'm going to split this thing on the pipe, which will give me this piece and this piece in a list. And then I'm going to use a list comprehension to strip each of the strings, which is going to remove the trailing and leading white space, right? And that way I will have a list, and we'll just look at this real quick. This will be my March 5th, 2021, and then approved. And I can unpack these two values into release date and then movie rating, and that will give me my two values here. So, just a kind of a nice, like maybe a fancier way of getting the March 5th, the release date and the rating. I think that you guys should, after this, maybe if you want to do some practicing, see if you can get these two values separately by using the methods that we've talked about today, right? Instead of just getting all the text from clamp details from this div tag, see if you can get each individual span tag in this case. All right. So now that we've identified the rules to extract all the relevant information, the movie title, the release date, the movie rating, and the Metascore for a single movie, and we've confirmed that our syntax works, now we can write a for loop to apply these rules to every movie in our list of TD tags, right? So we just did it for one movie, the first movie, and we just want to make sure that all of our syntax is correct and we're getting back the right values. Now that we know that's true, we can just write a for loop and iterate over the TD tags in our TD tags list, and then we can apply that same thing to each one of the movies, right? Each one of the movie TD tags. So all I did here is I took all of the stuff that we just did above and I put it in a for loop, and now TD is not just the first movie in our TD tags, it's going to be each movie in this iteration over our TD tags list. So for every single TD tag in this TD tags list, we're only doing the first 10 here. We're going to get the movie title, the Metascore, the details, and then the release date and the movie rating. Now, in this case, before we were just printing things out, but now we're probably, because we're printing out more than one movie, it might make sense to store it in a dictionary. And the reason we want to store it in a dictionary is, one, because we can use these key value pairs where the key is the column name and the value is the value of the whatever the field is. But this will make it much easier to write to a CSV later on. So we'll talk about that as the last step in our project here. But here we can see that when we print this out, it's going to make it a lot easier to kind of keep track of what's going on here. So when I run this, it's very fast, but we get back all of the top 10 movies and their Metascore and the release date and all that stuff. And we can see that it's all appropriately getting scraped in the correct way. And this is a good place to kind of go through and see if we have any missing values. It doesn't look like there's anything here. If we have a date for movie title in this place here, then we're gonna have to go back and check to make sure that our logic is correct. Again, like if we have a number here for movie rating or anything like that, that's something that we want to go and double check before we let this project run for real and like do everything, for example. Now, if this is only in one page, but if we were doing like 100 or 1,000 pages and this is running for hours or even days, we want to make sure that everything is being handled correctly. All right, so now all I did here is I removed this part, okay? So that now we're iterating over all TD tags in my TD tags list. So I'm going to run this, and we can see here that we're actually running into an error, where we're getting an error here. And it looks like that we got every movie up to Sophie Jones. So what I'm going to do is I'm going to go and search on this page for Sophie Jones and see what's below it and what's causing the issue. Does anyone see an issue here that could maybe cause an error in our code for this Mr. Rembrandt movie?
It doesn't have a rating.
It doesn't have a rating, exactly. Thank you, student in the audience. So that's exactly it. So for this movie, for some reason there isn't an element here, and when we try to split the date and the rating, it's going to give us just a single element. When we try to unpack that into these two values here, we're going to get an error because there's only a single element in my list, because when we did the split, there is nothing to split because there's only the release date. Okay. Now this is something that will happen a lot of times when you're scraping. There's always exceptions to the rule. There's always missing elements on different pages and things like that. You know, for the most part, things will follow a pattern, but there will always be little tiny changes and changes from the script, really. And you need to be able to be flexible and fix and handle these errors on a case-by-case basis. Okay. So in this case, the problem is because you know, we're getting the error here. So what I'm doing is I'm adding a try except block here that's going to try to extract these values, split and extract the values. And if I get an error, I know it's because, I hope, because the movie rating is missing. And that way I can just say the release date is equal to just the details thing and then strip it. And then the movie rating is equal to none. Now, this might be a problem if, for example, the release date is the thing that's missing and the movie rating is the thing that's there, right? Because in that case, I'm assuming that it's the release date that's actually there when really it's the movie rating. So if there's any examples where the release date is a rating, for example, then I might want to go through and just double check to make sure that I'm not getting this problem where the release date is the thing that's missing and not the movie rating. So now that I've run this, I can see and I can go down and now we can see we're getting no errors. There's nothing, we're running without a hitch, and we can see that we get all of our movies. So we've essentially scraped the whole page now. This is all of our information, but now the goal is to save it in something that is, we can use later, and we can maybe open it with Excel or maybe in Pandas or R or whatever data analysis tool you want to use. So in this case, what I did is I took all of the code that we've talked about today, and I put it into a single cell, and I've also added a CSV writing portion to it. Okay, and that portion is here. And I'm just going to quickly go through it. We've kind of talked about all this stuff. So here's my headers. Here's my response object. Here I'm making my beautiful soup object. And then here I'm opening up a file called metacritic.csv in write mode with a new line character. You don't have to worry about these two things, but this is encoding so that if there's any special characters. And then sometimes when you write to a CSV, it has these spaces in between the rows, which we don't want. So we say new line is equal to empty string. We make this CSV file, this file connection. Then we're going to use the CSV module thing here, which is going to allow us, it's going to help us write rows to our CSV file easier. So for example, if your data has a comma in it, right? If you have a string with a comma in it, you don't want your CSV file to think that that's like a new field, for example, because it's a comma separated value file. So this CSV module will help to package things so that if you do have commas in your text or in your values, then it's not going to think that it's a new field. It's just going to handle it for you. Okay. And then when we want to write a row to our CSV file, we use this write row method on this movie writer thing that we've created. And I'm just going to write a header row here by saying that movie title, Metascore, release date, and movie rating, and make sure that this is written in the same order as the keys in the dictionary, because that's how the data is going to be written when we write the values to the CSV file. So everything else here is the same except for how we get the TD tags, which is a little bit simpler. It's a lot simpler in the example I gave above. And then here we have everything exactly the same, except the very last thing is that we're going to take the values of my dictionary and write that as a row to my movie writer, which is writing to my file. Okay, so I'm going to go and write this or run this. And if you guys run this as well, this happens sometimes where if you the first time you run it, it's actually empty. So I'm going to run it one more time. And now we should see the CSV file inside our project folder, and we can see that we have our data. Okay, so we have successfully web scraped our data here, and we have all of the top 100 movies and their movie rating and their release date and their Metascore and things like that. We can see that some of these movies don't have a movie rating. I would probably go back to the page and just double check for these cases and see if there's a missing rating, just to make sure that I'm not incorrectly assigning a missing value to these rows. And then we should be good. So this is just one page, but we might want to do multiple pages or something like that, and that's more advanced web scraping. But hopefully you guys were able to get learn a lot from this lecture and kind of get a feel for what web scraping is like and what tools we can use to do the web scraping. Now, we have this Metacritic CSV file now, and we can use the data to perform analysis. It's not super rich in data, unfortunately, because we only really have the only categorical column we really have is the rating. So we can maybe look at are R-rated movies rated higher than PG rated movies or something like that. And so we can look at something like that. But maybe we could also get like the genre of the movie is a really important one. Lead actors, directors, budget, gross revenue, all this stuff. We could give us more dimensions to inspect and compare these different variables. For example, which genre of movie has the highest average rating so far this year? Is the budget of a movie correlated with the Metascore? Is the gross revenue correlated with the Metascore? This one should be pretty obvious that it should be, right? If the movie makes a lot of money, that means that people want to see it, which means it's probably pretty good, which means it probably has a pretty good Metascore, right? So, so a lot of these really important questions that are relevant for movie studios and producers, like what movie should we invest in? Should we keep going down the superhero movie track, which seems to have fallen off a little bit in the last couple of years, although they've been doing a lot of TV series that are superhero stuff now because they're releasing on Disney Plus and stuff. I don't know if you guys have been noticing that, but just interesting to follow these trends and use the data to try to make these decisions that will guide us and help us make money and optimize our business, things like that. So web scraping, super cool. Thank you all for joining. I'm sorry I went so over. I hope you found this useful. If you guys want to find more about our program, find out more about our program, please reach out to us. You can email admissions@newyorkcitydataScience.com. We have a whole bunch of offerings on our website. I put a whole bunch of links so you can't miss it. Applying for our bootcamp or any of our programs is free, and we'd love to talk to you and see if we can help you or find something that's relevant for you, even if it's not with us. If you want to find some program that makes the most sense for you to get you the next step, we'd be happy to help you. So give us a call, and we'll be happy to talk with you. Thanks for listening to me rant. Enjoy the rest of your evening, morning, or afternoon, and I'll hope you'll see you next for the next workshop we do here.
Thank you so much, Alex. I want to mention, I actually found a really cool project idea if you guys are interested to apply what you learned today with Alex. So if you guys use Instagram, there is a website, there is an account called Color Palette .movie. So they actually use the movie poster to generate the color palette. And you can totally streamline and automate the whole account. And guess how many followers they have? Alex, make a guess.
300,000.
1.6 million. When you get to that big, every post you make, you can charge a lot of money. So web scraping can be a good business. Cool, thank you. I really appreciate your participation. And we usually host event at least once per week, if not twice per week. Please follow our LinkedIn group and find out the latest event announcement. And we have a lot of talented instructor alumni to present their interesting project work. I hope to see you in the future events. Okay, bye everyone. Have a good afternoon, evening, and morning.
Thanks everyone.
Bye.